So let's talk about isomers first, because that was a question that came up earlier. So start by just writing down these four these four isomers. Well, let's not do it like that. Like, these stereoisomers, if I spelled that right, are a distereomer and an enantiomer are both a distereomer or a stereoisomer. So what we're going to do is I'm going to draw examples of them, and then you can explain to me why they are what they are. So this has whatever name, right? It doesn't really matter. This is our A. Put B up here. So what is the empirical formula for this compound and for this compound? So the abbreviated formula for these two compounds. So an empirical formula is when it's like C with the subscript, H with the subscript, and then in this case a chlorine, right? So how many carbons are in this first structure? C3H5Cl. Yeah, C 1 2 3 1 2 3 4 5 1 2 3 4 5 6 7. So did you get 7 and just type 5 on accident? So if you counted all the hydrogens here, right, there are 7, correct? Okay. So what is this one down here? How many carbons, how many hydrogens, and how many chlorines? Okay, so if this was an example of a constitutional isomer, what would the definition of a constitutional isomer be? What's the same and what's different? The same formula but different connectivity. Yeah, perfect. So that one, boom, check. So let's do this. So a stereo isomer, I don't know if that's how you spell it. A stereoisomer is going to have one thing. What's the requirement that a stereoisomer needs to have? And it comes from this part. The chiral center, exactly. So we'd go something like this. And I'll just use 1 through 4 but to show everything's different. So if this was our start, if we had one right next to it, and this was now 4 and this was 3, so let's say okay 1 2 3, but 4 is in front, so this must be an S compound, and then 1 2 3 clockwise with 4 in the back, this must be an R compound. So if you were to describe a stereoisomer, how would you describe it? What's the same and what's different? Chiral centers are the same, but the way the spatial arrangement of the atoms is different. So you could shorten that and say that it is the same formula. It's both C1, 2, 3, 4, but different configuration. So it's the same formula, but one is R, one is S, so same formula, different configuration. Does that make sense? Yeah, okay. So, if a stereoisomer has one chiral center, how many chiral centers do you think a distereomer has? So a stereoisomer is going to have at least one stereocenter. If it's a distereomer, it needs to have at least 2 chiral centers. So that di is an abbreviation for 2. So 2 stereoisomers would have 2 separate chiral centers. Oops. So if we did it something like this, does that make sense so far? Okay, so that makes sense so far. So here we've got 2 chiral centers. We've got a chiral center right here and a chiral center right there. So if this was our first molecule and we were to determine the S and the R of these 2 things, we can do that just as practice. So we know that this is definitely group 4 and this is definitely group 1. Well, this is going to be group 2 over here, and this is going to be group 3. So to go to, we would go this way. So what, that's counterclockwise, so there normally would be an S, but our hydrogen is out front. So that makes it an R for this stereocenter. And then over on this side, well, we know hydrogen's definitely going to be number 4, chlorine's definitely number 1. This is way bigger, so this will be number 2, and this over here will be number 3. So then we want to go 1, 2, 3. That's clockwise, and hydrogen's in the back. So that is going to be an R configuration. So our compound here is an RR dichloro hexane. We don't need to get more specific, it's just an example. But if we were going to draw a distereomer, how many different centers can we change here? So if we only change one, that is an option. But what would happen if we change both? Right, exactly. So if we change both of these to S's, it's an enantiomer, so it's a mirror image. It's like your hands. So there's my left, this is my right. They are exact opposites of each other. Everything, they're non-superimposable. There's always gonna be some sort of distortion between them. Where with a distereomer, you have to change one or more if there's more, but if you change all of them, you end up with an enantiomer. So if we change this to S and leave this R, or change this to S and leave this one as R, those would be distereomers. So the equation is 2 to the n. So n equals the number of chiral centers. So we could have 4 different options here. We could have RR, SS, RS, or SR. Those would be our 4 separate stereomers. And we will go live later.